everyone, so I'm Alex. I'm going to be here to talk about how we enable search on billions of docs at RAMP. So just quickly going to go through about myself, about my team, about RAMP, why do we need search, and about our current journey. So just a quick thing about myself. So I'm currently in the data platform team, and our focus is about data. Data is super critical to our strategy, and we want to supercharge data usage across analytics, AI, ML, and search. And specifically myself, I'm in ML platform, and I'm leading search. So if you haven't heard of RAMP, the way you think of us is we're kind of like an all-in-one finance platform. So that means from your single place, you can issue cards, make payments, automate expense reports, and automate accounting. So our goals is to enable companies to reduce the amount they spend and automate the tedious work away. So I guess, why do we really need search? So at RAMP, we have a rich corpus of financial documents. So across 30 different document types, we often have multimodal documents as well, such as images and invoices. So we needed a way to scalable way to retrieve relevant results across all these document types to power both our UX and our AI use cases at a very low latency. So in our quest to improving search quality against such a varied document output, we kind of settled on using hybrid search here. So hybrid search combines both vector search and full text search. So as most of you would know about vector search leverages embeddings. Embeddings is just a translation of our inputs in a way that we can measure and do math, essentially. Taking something unstructured to structured so we can find similar meaning across these docs. So we've come to the conclusion that vectors can only take you so far. And alongside with full text search, it provides us a powerful search outcome, semantically relevant search results that matches on keywords. So having a better search platform allows us to power great UX for our users. So a great example of this at RAMP is our Command K search. So it's a one-stop search for anything they need. So I just have a quick video demo of this. So you can see in the search, let's say we search accounting services, the user, and it pulls out PwC, particular for that user, or a specific invoice number, and pulls out the relevant invoices. So this is kind of Command K search, a search platform for our users so they can find anything that they need from their financial kind of documents. Another great outcome of having this kind of search platform is we're improving our AI outcomes. In particular, for example, helping us improve our AI outcomes for our users. For example, a big part of finance automation is categorizing invoices. And the best way to categorize something is to find a previous example, simply reuse how it's coded, or provide the LLM the right context to help code it, because there's no better predictor than the past here. So to enable this, we need to find similar documents. So again, I have another kind of quick demo here. And this is our demo of our multimodal embedding workflow action, essentially where I'm going to upload a very redacted invoice screenshot. And upload, it's just an invoice, it's an image itself. Find the relevant invoices, and you can see that we're able to find the relevant invoices from the past, specifically here, Turbopuffer. And you can see this just scratches all the UI use cases that we currently power at RAMP. Knowing how to find anything relevant towards your particular search context, and your search input nowadays is no longer just text. It could be images as well here. So in other words, search is not just for text. Context is everything. Actually, no, hold on. After listening to Simba's earlier talk about context engineering 2.0, context is all you need, I guess? No, hold on. I think I've seen quite a few t-shirts around the conference here today. So I have to update the slide one more time. Context rules everything around me. So I'm going to now talk about So now you can kind of see how we need kind of search a ramp and how we currently use it today. So I'm going to go through our current journey and just a bit more of like our pipelines to enable this. So Turbopuffer is our current search engine provider, and it has helped us enable hybrid search at billions of docs at very low latency. And we've only just begun our migration around September last year. So my teams did a great job before I started of a great evaluation about why they decided to procure Turbopuffer here. And they've been a great partner here in helping us develop that search platform. So pretty much all your docs, every single doc has ramp that we kind of embed and search on. We denormalize it. We denormalize it from a whole bunch of Postgres tables into its vector and attributes. So each document itself is enriched with much more information, relevant and searchable at runtime. And so search can now become a bit more opinionated in its use, leading to better search results for specific use cases. So an example of which, for example, is we have a whole bunch of transactions that come in. So when you swipe your card, the transactions. And with transactions, we could tie with all a bunch of informations that we want to enable full text search on, such as the memo, description, like the payee, the merchants, anything like that. All of these are searchable attributes that are relevant to the users. And so here's just a quick overview of our data ingestion pipeline. So it follows a classic enricher model. So whenever a row changes in Postgres, our DBZM captures the change and then publishes the CDC event to Kafka. And then from our enricher, we consume the CDC message, queries Postgres to pull in all that additional table from across those particular different Postgres tables and produces an enriched message back to Kafka, where we eventually perform inference to generate the embedding and eventually write it out to Turbopuffer here. So here's a quick practical tip on for us is about how we kind of reduce costs with hash dedupes. So writes are generally like the most expensive operation here. So we effectively backed our search store with 2 hashes. And generally these hashes tell us whether to write the new document or to patch the documents, effectively reducing our previous cost by 70%, where we're writing a lot less now when we're really just patching attributes that we want to search on and not the actual vector which the database is indexed on. Cool. So that's all I have, and we're hurrying.
I think we have a time for a question for Alex.
Graphs must come up in your graph search, must have come up in your debates. You sort of entity resolution kind of thing going on here. What do you think about that?
So that's kind of really next steps for us. We really found that hybrid search as it stands right now, before we even get to the graph, provides us provides us so much value that for us, now we're really starting to explore what is next. So I think we're really excited by the context, like search in a context kind of graph. We're really excited about agentic search. I think we're at a point where hybrid search has really gotten us to a really great point where it's actually reached a point for us where because we made search so easily opinionated with all these searchable attributes and our richer workflow, it's hard for us to create the business case internally to work on something kind of different at the moment. But eventually those days will come, but yeah.
Please.
Yeah, hybrid search you mentioned.
I'll give you a microphone so folks in the back.
So in the full text search, in the hybrid search, you mentioned the BM25 as the full text search.
Yes.
Since your company is mostly finance related stuff, did you tried out a splayed sort of like a sparse model, BERT models? Because it has more context enrichment search as well, additional to your vector embedding.
Yeah, it is a consideration. I think for us, we wanted to leverage what was out of Turbopuffer, and they were pretty much focused on BM25 as that full text kind of search. And for us, I think we're kind of evolving from just like a bit of financial transaction, just a small bit of information. We're going to like entire financial documents, policies, like a company's financial policies, anything like that, and where it's really been having that. BM25 has been really great from what we've seen, especially at that longer document length.
Cool. Cheers. Thanks.
I think we have time for one more question. Please.
It's kind of forward-looking, but do you have any like validations or guardrails when you do these things? Like what happens when you get it wrong? Or because this is financial information, is probably super important that you get it right.
So getting it wrong always kind of sucks here, of course. But I think a great part about, if you see like a lot of like accountants' workflow, they do a lot of coding, they do a lot of like actual manually defining what a transaction is, what the invoice should be, and they often go back a lot of things. And I think for us, it's never going to be perfect, and it hasn't going to be perfect, but it's only going to keep getting better at AI outcomes for our users, right? So I think for us, concerns about it getting searched wrong is much less. We wouldn't plug this particular system into those kind of sensitive outcomes. These are more like additives, so providing better context so the LLMs can actually do what is needed here.
Please go ahead.
Does it do what can you run a validation, say, if you were trying to do a search on a specific invoice from the client? Could you do a validation where it does all the searches and it finds 10 instances and then adds them?
Yeah, so my presentation doesn't even go into the re-ranker that goes on top, because a lot of what comes along is you find those semantically or similar kind of document types. But what is generally the best practice is you add a re-ranker on top, because there are small minor details that your similarity search may not be able to differentiate. So once you do find your top K, it's always preferred to add a re-ranker on top to help find the right document at the end. Yes?
Are you able to change the similarity metric being used in the text search on the fly, or how do you got pre-canned ones?
Yeah, so the metric that we're just using is just purely ANN, anything like that, or just like distance metrics at the moment. And you can choose which distance metric that you prefer is better, because it's just a calculation in the end.
Well, the distance for vector spaces, in text you got how many characters are flipped between the two, that kind of metrics are being used in the text search. So in the pure text search, what metrics do you use for similarity between the text?
Right. No, so in those particular scenarios, it's just there's a score that gets outputted with BM25, and then with our hybrids, so we do have a parameter that we tune, is how much do we want to favor full text search versus similarity. And this particular tunable is all customizable to our product teams about how they want to opinionate themselves. Because you can imagine that for a particular team, they may want to just focus on retrieval for a very specific invoice number, a very specific code that a team uses. So they will focus a lot more on full text search. And so hybrid search is really that bar that is customizable to the user here.
Thank you, Alex, again.